What my research is involving is we are looking at the water availability under different climate scenarios within East African countries. Right now we're focusing on Malawi, but we're going to expand that, I think, to Cambodia and a couple others. The model we use is a SWAT model. Soil Water Assessment Tool is what SWAT stands for. And so this takes into account a whole bunch of different layers, including soil types, rainfall, temperature, all sorts of different soil categories, slopes, things like that. And based on that, we can simulate river flow. So then we take those models and throw in future simulations of precipitation and temperature and use that to determine what our stream flow, groundwater, all the water available within the soil will be like under these different conditions. And then that allows us to determine how much evapotranspiration there'll be, how much runoff there'll be, soil moisture content, all things that are very important for crop growth. And so then we can, in theory, relate that all to crop yields.
I'm part of a group that studies agriculture in that region, and the way I study it is through satellite imagery. And what I'm doing is assessing agricultural variability across the country. Different trends in production over time and also across space. So at different latitudes and different scales.
So we can say here we're going to have regions that are going to be very stressed for water, which is going to reduce the yields of the crops. This is showing the precipitation and temperature stations on this one, and this is where we did all the different calibrations. So this is the actual map for Malawi, and the different watersheds that we have. Each of these different colored regions is a different watershed within Malawi. But actually it looks like there's not many rivers within this watershed here. But the rest of them have all these little blue lines are the rivers within Malawi. And so each of these we calibrated a different model for to make sure that it was more accurate to the region. So we'll look at all the operations that they go through, when they put fertilizer down, if they use fertilizer, when they plant the crops, when they harvest the crops, what tillage systems are they using, and all these have impacts on how the water is either retained or lost from their sites. And so we can get more specific eventually and look at different crops and see which ones are more impacted versus less impacted based on climate change scenarios. As the years progress, it's a steady downtrend. So there's going to be a lot more heat in the atmosphere when it gets to that point. More heat means more evaporation. You have more water in the air, less water on the ground, which is a big issue. And then you also have the issue that populations continue to grow. And so you're going to need more food, you're going to need more irrigation, more crops to sustain population.
Overall, there's a decrease in productivity for the whole country, the entire country average. And we see higher productivity in the north and less in the south.
The region that we're looking at is divided into subbasins. And normally each subbasin represents one stream segment. And so for each stream segment, we'll have different parameters that will be tweaked and changed to hit the point where it's calibrated. And so with this will give us a clue as to identify which regions will be most impacted by climate change. You could have some regions that under scenarios get more rainfall, in which case you may have to figure out ways to remove water from the fields to make sure that you don't flood the crops. And there's other regions that could get more droughts, and then you have to figure out, well, now that I have a drought, I still need to produce food, I still need to have a crop yield.
There are different groups that want to implement things like climate resilient maize that are going to improve agriculture in Malawi, but they don't know where to initiate these trials. So that's something where my expertise can come into play, studying how maize production has changed over space and over time, and I can help pinpoint areas where those varieties of maize will have the biggest impact.